Alright, so I've been wanting to make this video for quite a while because I want to show you the true power that is working with a model kit in organic chemistry. So the problem that we're faced with here is we're looking at this Fischer projection and we're saying which of the perspective drawings, A through E, are the same exact, or in other words, an identical compound as the Fischer projection, okay? Now, in my guide here, I did go through how to do this on paper in terms of using the RNS system, interchanging out substituents as needed, and kind of going from there to find out the answer. But I want to show you how quick, easy, and dare I say fun it is to actually use the model kit for this. All right, the first thing you want to do is actually build the Fischer projection for this compound, right? And we're going to start with a carbon, as we often do, okay? Now, if you remember, you need to remember this kind of fish mnemonic for Fischer projections, where you have this hatched wedge going north and south away from you, and you have this bow tie wedge that is coming towards you. We need to keep that in mind, that that is what translates a Fischer projection into a model kit, and then a step towards putting that into a perspective, right? So in order to build this, we have the carbon in the center, and we know our methyl group and our hydroxyl group are going to be going away from us, and our hydrogen and this cyanide here are going to be coming towards us, all right? So, and just look how fun it is to actually look at your substituents. And look at this. You have your methyl group, you have your cyanide with the triple bond to the nitrogen, you have your hydroxyl group, your oxygen, and your hydrogen, and then you have just your simple hydrogen here. So we're going to start with our carbon, and let's start up top, right? And literally you can put this anywhere. We're going to put our methyl group here. So we definitely know we want it kind of pointing upwards, but we want it pointing away from us, okay? Now next we're going to put opposite of it our oxygen, our hydroxyl group here. So we're going to choose this hole here, and we can already see this shaping up, and you can rotate this hydroxyl kind of about its bond here. We're going to put it this way, and you can already see that our methyl group and our hydroxyl group are both pointed away from us, and one is going up and one is going down from this perspective, okay? So you can see we have a hole right here on the right. I know it might be a little hard on the video, and a hole right here on the left. So we're going to go ahead and put in our hydrogen first so it doesn't roll off the table on the left side, and then we're going to put our cyanide here on this side. So here is this compound, and you can see it clear as day. You can see the hydrogen is certainly coming towards us, and the cyanide is certainly coming towards us. Now keep in mind, coming towards us doesn't have to mean straight ahead. Coming towards us just means, in a way, in the direction, towards us, out of the plane of paper, whereas these ones are going toward, away from us into the plane of paper. So just keep that in mind. But this is most certainly this compound as we see it in this Fischer projection, but as a model. And I think I already built this. Yeah, I built this same exact model and took a picture of it earlier. We're looking at it a little bit more head-on in that picture, as you can see right here. Okay, so now what do we do? So we're comparing it with these other models here. All right, well, what if we just try to build another model? And yes, absolutely, I have all of these extra substituents ready to go. And you'll be surprised at how quickly you can build this stuff in the middle of an exam and how helpful it is. So we understood how we could create the model of a Fischer projection, but how do we create the model of a perspective? Well, it's actually fairly easy. We're going to take a carbon, All right, and we can do a couple of different things. We know that hydrogen and the methyl group are in plane, and we know that the cyanide and the hydroxyl group are wedged, and the hydroxyl should be coming towards us and the cyanide should be coming away from us. The easiest thing to do here is start with our in-plane substituents. So we're going to start with a hydrogen, and literally you could put these two anywhere. It's the placement of the other two that are going to be important. And I want you to really understand that, right? The hydrogen, you pick literally any hole, and then the methyl group, I'm going to just choose this one here. It really doesn't matter because I can put these in plane. You see how this almost looks like an antenna of the H on the left and the methyl on the right there? It almost kind of looks like Mickey Mouse in a way, where we're looking straight at the carbon here, and we see the hydrogen coming off on the left, and we see the methyl coming off on the right. And they're in plane, right? These are the same plane because I can hold them in one direction and I can rotate this around. They are on the same plane, okay? So now, where do we put the hydroxyl? Where do we put the cyanide? Well, look at this hole that's coming right towards us. And look at it says the hydroxyl should be coming towards us. So that's probably a pretty good spot to put this group here. So what is left is the cyanide, which needs to be on a hatched wedge going away from us. Now this doesn't look exactly like the perspective drawing. I actually think Fischer projections are much more powerful in terms of visualizing a molecule. But look at what we've made here. We have our hydrogen going off towards the left. We have our methyl group going off towards the right, and they are in line. Our hydroxyl group is coming towards us, as shown in the perspective drawing with a solid wedge, and the cyanide is going away from us. So this and this are the exact same compound. And literally, keep in mind which one is which, I can bring in the compound that I made earlier, and literally all I have to do is say, am I holding the same exact thing? All right, well, how do you figure that out? I usually like to kind of put them down. So let's see, I have my cyanide kind of pointing upward, and look at that, right? These are not the same compound. These are mirror images of each other. We just made a pair of enantiomers, okay? If you don't believe me, and you think these are the same thing, well, they are not superimposable. If I were to try to superimpose one on top of the other, you see the hydroxyl is coming off this way, the hydrogen is coming off this way. No matter what I rotate, I can't make this molecule be this molecule. This was my original Fischer projection. This is the perspective drawing I created. These are two different things. So A is not an identical compound, so we can rule out A. C we've already ruled out because there's two hydrogens here. C is a trick. This is not a chiral molecule at all. It has two hydrogens, so we just have to look at B, D, and E. I'm going to put my Fischer projection just off to the side here, and let's build B. Let me show you how quickly you can build B. Let's start by putting our methyl group and our oxygen in plane. All right, I have a methyl group kind of going towards the left, and I have a hydroxyl going in plane towards the right. Aha! But the hydrogen is wedged in this case. The hydrogen we want coming towards us, and the cyanide we want going away from us. This is this molecule here, okay? So this, we kind of have this reverse Mickey Mouse, where you have the head of the mouse here, and you have the ears of the mouse, which are your in-plane, your hydroxyl, and your methyl group. And this hydrogen is kind of pointed straight at my head in a way, and I know that's coming towards me, and the cyanide is pointing away from me. So this is B, and I can put this down on the paper, on the table here, and I can ask myself, well, are these identical compounds? And you can clearly see, clear as day, absolutely. These are the same exact thing. You know, these are not mirror images. These are the same exact. These are the same exact compound. Or they're not. They would, you know, a mirror would still work technically, but they're not non-superimposable mirror images. If I put one on top of the other, everything is lined up. So B is definitely an answer, all right? Well, let's look at C real quick. We have our hydroxyl and our hydrogen in plane this way, all right? Hydroxyl going off towards the left, hydrogen going off towards the right. We have the methyl going towards us, and oh, sorry, we already ruled out C, so we're moving along here. We're going to look at D. We see that our hydrogen and our cyanide are the ones that are in plane. So we're going to have our hydrogen kind of pointed downward like that. We're going to have our cyanide pointing upwards like that. But however, our hydroxyl, and just the fact that I have to take something off is a clue that this is not an identical compound, okay? You should know that all we're doing here, now we have again, these are in plane. This is always how you want to get your bearings when you're making models like this. The methyl group is coming towards us and the hydroxyl is going away from us. This is the compound in D. If we put this next to this model here, we can see that these are in fact mirror images. These are not identical compounds. The last one we have to do is E. All right, let's take our hydroxyl and let's take our hydrogen and we're going to put them in plane. This is our kind of classic Mickey Mouse setup where we have the head of our mouse and we have the ears here. And all right, we want the methyl group coming towards us. We want the cyanide coming towards us because you can see the solid wedge. And again, little clue that we're making a switch here. So this should show us that, in fact, you can see the cyanide coming. Now it's pointed kind of at my belly button, but it's still coming towards me. This methyl is clearly pointed away from me. And these are my ones that are in plane, the hydrogen and the hydroxyl group. But if I put this down on the table, I can in fact see that these are identical compounds. So there you go. So the answer is B and E are the same as this Fischer projection. Now, the faster you get with, B and E are both in the R configuration. B and E is the answer here. The faster you get with the models, you'll be shocked at how quickly you can build this and go through all of this without writing anything down, without having to look at all the work you have to do. You need to interchange all of these groups. Then you need to rank and do your R to S system. Then you need to do, is it clockwise or is it counterclockwise? Well, if I swapped it, I have to switch it. Look at all the room for error. And you have to find the R and S of Fischer, and remember that R and S has different rules for Fischer projection and perspective drawings, where a perspective you need to switch, interchange groups. Fischer projection, if your fourth priority is not on a hatched wedge, you just switch it automatically. That's a lot to remember. That's a lot to draw. That's a lot of room for error. Building the model for this is absolutely foolproof, and you cannot get this question wrong. So I really wanted to just show you that, the power of working with models, and hopefully you found this helpful.